All right, our next speaker is Julio Rezende. He is involved with Habitat Marte in Brazil, and this talk is on engineering on Mars. Take it away, Julio.
Okay, thanks so much, James. Congratulations for the Mars Society convention. And then this is a presentation with my colleagues, Davi Souza, Saikiran Pahe, Miriam Nassim, and Jess Burwell. The presentation was developed by Jess, okay? And then we'll be talking about engineering on Mars. And then some topics that I'd like to talk, okay, is about some general responsibilities of the engineering facility, potential construction methods of engineering model, possible layouts concepts, normal duties, also crew requirements, contribution to food production, and thus some activities and recommendations for the rest of the crew, okay? In terms of general responsibilities, we consider that we are imagining our operation of a Mars habitat. This Mars habitat contains 7 infrastructures, and then one of these 7 infrastructures is the engineering center. Okay, and then this presentation is about specifically about this infrastructure. And then some general responsibilities of this facility called engineering center is maintenance and repair the all stations. Also, it's very important to take care about the vehicles and the rovers. Also, ensure that each facility keeps the all maintenance and repairing protocols. Okay, and then also some new technologies also will be developing during the Mars permanence, okay? And then other different activities, okay? And also provide some technological solutions to other facility in the Mars habitat. And then here you can see a concept, okay? Concept about some the habitat considerations, and then is necessary to protect from the dust storms, also protect from radiation, and then also provide a good comfort to the crew. Also protect from the atmosphere and the environment that will be found in Mars. Also life support, also cost of the materials, time to construct, and other aspects as maintenance. And then we examined some potential construction methods, and then we found that the sulfur concrete made with Martian regolith would be a good technique because it's twice as strong as Earth, and also is a sustainable material because the resource can be found in Mars. Okay. Also, would be used the solar rays to melt the sulfur. Also, other aspects like also you need to consider that it's not resistant to high temperature, but it's possible to consider other options like use the 3D printing techniques, and also use an inflatable habitat and caves and lava tubes of Mars, and maybe a combination of all of these possibilities. And then you can see some considerations about use the sulfur concrete. Okay, in this case, we'll be using. It's possible to use the additive manufactured. And then you can see a representation in this photo. Also, we can see in this slide different techniques like the foundation robot, also a grip robot, and also a vacuum robot too. Okay, and then this is a part of a research developed in Spain. Also, there is a very popular model that also I watched a presentation last year during the IAC Congress in Washington, D.C. is the Marsha technology. No, is a very interesting technology. Also, they receive award during a contest, and then there's very interesting technology to be considered to build a 3D printed facility. Okay. Here we can see the a figure done by Team Peak. Okay, it's a astronaut selection textbook, and then you can see in the image different possibilities like use a lander on Mars, also build a habitat from a inflated dome. Okay. Also, sometimes we are considering a possibility of do a dome with this dome be coated with water, and which freezes with the time. Also, a fourth possibility would be a permanent habitat. Okay, using 3D printing technologies. Okay, and then so here we can see some images, some conceptions, also the credits. Possibilities of glass that protects from radiation. Okay, you can see some research of the mass shield technology that separates the receives the lightning, but it's also protecting from the cosmic radiation. In the concepts proposed by Jess Burwell, the main author of this presentation, she considered that the engineering center would have two levels. Okay, and in the floor level, we would have an area for the rovers. Okay, rovers and vehicles that will be used to collect soil samples, not samples, but soil to be transformed in raw material to be used in the process of the additive manufacturing. Also, the engineering center would be very important to collect the ice to be melted, to be used in many different activities in the space station. And then, in this case, in the floor level, we will have the vehicles parked here. And then also, as part of this facility in the ground level, we have also some tools and also activity aspects related to also research in innovation, also research the material collected in the Mars landscape. And then in upper level, we will have a workout area, also the storage, also a rest area, and then hygiene facilities. Okay, this was the design proposed by Jess Purwell. And then you can see in the walls like a vertical garden in the walls, where will be cultivated some food for the like salad and lettuce and other plants in the walls. And then in the engineering center, we have some normal daily duties like the maintenance and maintenance of the station, tools, the maintenance of the vehicles, maintain the space suits and drones. Also take a look about the health and safety checks, also analyze the risks and also test equipment, and then also monitor the best practice and also support the entire station. And then the engineering center is very important to provide support to the main station, because in the main station you have a lot of engineering stuff like the information and communication technologies that will be used to communicate, establish the communication with Earth, and also support the guidelines and activities to food production area. Also give support to medical research and also the power station. You can see operating the power station solar panels and also the kilopower technology and other tools. Okay, And then in terms of the size of the crew, you can imagine a crew of between 3 and 6 astronauts, okay? And then we believe that the most suggested quantity will be something around three astronauts, okay? Because we know about the limitations in terms of the astronauts to be operating the Mars habitat. And then we did some calculus about how many kilos of food per meal, and also the quantity of water to be consumed for bath, and also to prepare food, and also to be consumed. And then part of this food would be generated in the vertical garden inside the engineering center, okay? But it's a great challenge, okay? And also the engineering center need to provide a lot of guidelines for different infrastructures of the Mars habitat, okay? And then we can, part of the research is connected to the food production area, okay? Considering some elements related to food production. Also, it's a important skill related to the engineering center is reflect about the technologies to provide lighting, because we can see this concept here, like the food production areas, the greenhouse protected by regolith, and then sometimes we found some reference in YouTube showing the fiber optic cables collecting the lightning and outside of the station, and conducting this light through the optic fiber cables to the inner area, okay? And then using different also LED to the operation of the greenhouse area. Okay, and then also other worry about the operation of the engineering center is related to some possibilities of the dust storm activities, and then this means that we need to develop new methods to dust removal from the station, also ensure backup and emergency systems operating correctly during this time, also monitor the environmental conditions during all the moments, because like if you imagine that dust storm is coming, a lot of alerts must be released to keep all the crew prepared to a dust storm impacting the Mars habitat, okay? And then this relates to identify possible risks, also maintain the local food production, also maintaining engineering tools, and other important elements related to the operation of this facility, okay? And then we have some recommendations for the crews, like is related to regular system checks and maintenance, because you don't know how will be the operation of some systems is exposed to dust and also cosmic radiation, and then some tools during the long time of use, the tools would be damaged, something like this. And then this is part of our worry related to the operation of this Mars habitat. And then the engineering center would be providing guidelines to all the crew related to the engineering aspects, okay? Also sharing reports with the main station, maintaining the safety procedures, also alerting some problems related to some strange patterns of data, like if you have if possible, sometimes identifies like low humidity or some possible problem related with the air circulation, or maybe problems with energy in the station. And then the engineering center needs to identify quickly these possible problems to identify the best solution for it. Okay, and then now I'd like to share some reference of this presentation. Okay, and then let's see here. Okay, as I'm finishing the presentation, and then I open to questions. Okay, and then just to complement, maybe I have a little time. This is a result from a mission, a virtual mission developed in the Mars Analog Station Habitat in Marte. And then we developed the presidential missions until March of this year. Then happens the coronavirus, and was developed the methodology of virtual missions. And then now we have participants from many parts of the world in these missions. And then this presentation was done by Jazz Purwell, based in England. Okay, and thanks so much for your attention.
Thank you, Julio. Looks like we have one question, I think, from Cranjus. How come we gave up so easily on traveling to Venus?
Yes, I believe it's a good question. It's a good question. Yes, I'm not thinking yet about Venus. Okay, it's something new for me. But maybe we are more focused in the Mars studies, but we just developed a mission, a virtual mission related to the moon studies. Also, I presented the paper in the other event that you were organizing, James. And then, but we are interested to research in the future, maybe have a mission to think about the technological challenges related to the Venus exploration. Yes.
Mm-hmm. Any other questions that folks have, feel free to unmute yourself and ask.
Hi there, this is Patrick. I was curious about if you had given any thought to the removal of the dust. It seems like kind of a hard problem and sort of an easy problem at the same time. Just any thoughts around that?
Yes, I consider that the dust will be a big problem, because also in terms of the facility that we imagine to be operating in Mars, I consider that the engineering center will be more painful area, because the astronauts of this facility, they have a lot of activities to do, intravehicular activities, and extravehicular activities. Great part of these activities, extravehicular activities, are related to clean the stations and some critical areas, because depending of the size of the dust storm, this would be very disturbing, because you can imagine areas to keep the vehicles protected from the dust storm. And after the dust storm, you need to clean up all these vehicles, and then it's something easy to deal with it. Okay, but and then also something that you need to think is the possibility of the dust in the spacesuit, and also contaminates the station with some pathogens, some bacteria, I don't know, or virus, and also bringing a lot of dust to inner areas. And then part of the research challenges is to think about how to avoid the dust and the particles inside the station. Okay, and then this is a very interesting topic of research and development.
Thank you.
What's the first step in establishing a civilization on Mars? When we get there is a question of cranks, and then we are imagine they will be using models to arrive in Mars, and then the first models will be like the main station, and then will be very challengeful. You keep the activities with limited elements and also limited food, and then also depending of other missions bring more equipment and also more raw materials or more tools to be used in Mars. And then yes, this the first moment for me is very critical. Also we have the Netflix series The Away, showing the challenge to arrive there. And then we need to have a backup. Also, I believe the analogy missions are very important. Also, the Mars Society Convention discussion is very important too, in terms of imagine these the possibilities of risks impacting the human settlements in Mars, and also not only the moment of settlement, but the moment of traveling to there.
Okay, any other questions? Feel free to unmute and ask.
Also, I'd like to share my email here, okay, in the group.
Yeah, please do.
My email, and also this my profile in Twitter.
There's a question there. Do you see that? What is the next destination beyond Mars in the future?
Also, I'm sharing the profile of Instagram of Habitat Marti. Okay, and then
Thank you.
thanks so much.
The question, what's the next destination beyond Mars in the future?
Yeah, good question. I believe Venus would be a good option, no, but we need to develop more studies about the Venus atmosphere. But this question is limited by our propulsion systems technologies, and then you need new kinds of propulsion systems to have a better answer about it. Okay.
Okay. Any last questions before we end? Or comments? Okay. Okay, Julio, I think that we're good here.
Yeah.
Thank you so much for your presentation.
Okay, congratulations, James, for your beautiful work and commitment. I also are very enthusiastic of your volunteer activities. Okay, thanks so much for you too.
I appreciate that, Julio, very much. Thank you.
Mhm.
All right, take care, everyone.
Bye. Thanks so much, guys.